Hi guys, this is Mr. Urrego, and today we're going to start reviewing for the EOC exam, the Geometry End of Course exam. This is an exam that most people in the United States have to pass in order to graduate from high school, and we definitely want to graduate. Okay, so today what's going to happen is we're going to use a practice test, which is called Beat the Test. This is given by the county, therefore it's official, and it's very similar to the questions that we have on the regular end of course exam. Before we start, I'm going to talk about these three resources. So the first one is the geometry reference sheet. This is where you're going to get on the day of the exam. Okay, so you have access to this. So you want to get familiar with this. All right, there are units, convergent units, and the second page is about sine, cosine, tangent, a couple of volume formulas, and the slope of the line. All right. Next one, EOC calculator. This is the official calculator that you're able to use the day of the exam. Okay, here's on the bottom. It's kind of a little bit weird. Fractions here on the bottom, x squared, square root, sine, cosine, and tangent, the inverse functions to find the angles, to raise to a power, a radical. Get used to it. All right. Third one is the equation editor tutorial. So some of those answers that you have to input on the exam, you have to write equations. Okay. So here's a tutorial that will explain you how to do them. Please do not wait to the day of the exam to practice on this tutorial. All right. Do not wait. Make sure you practice beforehand. So this is going to make you feel comfortable the day of the exam. Okay. All right. Let's talk about the exam. So right now, this practice test is 52 questions. All right, 52. Out of those 52 questions, we have 27 questions that are relating to this category: congruence, similarity, right triangles, and trigonometry. 27 questions. This category makes a 46% of the total questions of the EOC. So if you're strong at this category, almost just with this category and a little bit more questions, maybe heading to a 60%, you're able to pass the EOC, and you're done. So we might want to pay attention to this. Almost half of the exam is about this category. All right. So let's start. All right. We're going to start with question number one. Here we go. So for question number one, let me get a pencil here. All right. Question number one. They give you a drawing. They give you a figure. Consider the following figure. And on the bottom, they ask you, select all the statements that apply to this figure. Statements. So it means there's more than one. Okay. Be careful. There's a little trick there to know that there's not only one answer. Let's start. Line K is perpendicular to line RX. Line K, all right, is perpendicular to line RX. RX is in the middle. X is right here. If you see, there's a box right there. Box means 90-degree angles. So yes, they are perpendicular. They make a 90-degree angle. Next, line RZ is congruent to GR. R is in the middle. Z here is in the space. I have no idea where's that landing. It says that it's congruent to GR. G is here in the bottom, R. Guys, in geometry, we're not able to assume. You cannot assume anything. Oh yeah, they look similar. No, you cannot. All right, they need to have marks, like the 90-degree angle. We know they're perpendicular because you have a box. It means 90-degree angle, so you can't assume anything. Because there's no marks, there's no congruent segments, or tick marks. That's wrong. Next, points X, B, V, and N are coplanar. Okay, coplanar means they're on the same plane. So let's see. X here is on the top, B is right next to it, V is all the way in the bottom, and N is next to it. So all those 4 points belong to this shaded plane. Yes, they're on the same plane, so yes, that is true. Next, plane F contains 6 points. We can name a plane using one letter. Normally it's going to be in a corner, which is this right now. So plane F, this gray shaded plane, contains 6 points. Let's find out. V1, N2, R3, B4, X5. I don't see any other points laying down on this plane. F, as it is just the name of the plane. It's not a point, you see? Next to X, there's a point. F doesn't. So there's only 5 points. So this next statement is wrong. RH is part of line K. RH is right in the middle. H is down here. Is part of line K. Line K is here. It goes through the plane. Definitely not. It's not part of the lane, right? Wrong. Line VN is headed the same direction as RH. VN is here in the bottom. It's headed the same direction as RH. No, there's no statement. There's no arrows meaning that they're parallel. There's not really. And they don't even look, they're going to the same direction. So no, at all. Line RG is the same as line K. RG, R is in the middle, G is on the bottom. Yes, line K. So yes, those are different ways how to name the same line. So yes, we can see the extension right there. Same line. Okay. Question number 1. Let's go to question number 2. Next. Okay, so we have now this drawing with a bunch of lines. They're asking me, which of the following statements are true about the graph? Select all that apply. So it's more than one. Next, first one. TU is the result of a translation of RS followed by a rotation. So TU, where's TU? TU is on the right side. Translation of RS by a rotation. RS. Okay, by rotation. So if they're saying it's a translation and then a rotation, we need to understand that those two lines have to have the same measure. Okay, so this is possible. This is possible. So let's see. So this TU line is 1, 2, 3, 4, 5. Okay, TU is 5. Oh, RS is the diagonals. How can I tell? So it's an easy way how to find out how long is this. I just make a right triangle and I use the Pythagorean theorem. So right triangle, the base is 1, 2, 3, and this side is 1, 2, 3, 4. Okay, so if my sides are 3 and 4, Pythagorean triple. The hypotenuse is 5. That's a Pythagorean triple. I will link a video to Pythagorean theorem on the description. So yes, this RS is 5, TU is 5, and they're saying TU is a translation of RS by rotation. They have the same length. So yes, translation, I can move to the right and then I can rotate and make it horizontal. Yes, that's possible. TU is right. Next, AB is the result of reflecting GK followed by a rotation. AB, this is AB, okay? There's an A on the top here. AB is the result of reflection by GK, reflection. Not really. That should be like a rotation. So no. Followed by a rotation. Okay, hold on. They're saying a reflection followed by a rotation. So let's see. Easy way how to find out is the measure. Let me erase this and let's find out how long is each segment. So AB is 1, 2, 3, and 4. Okay, they're saying it's the result of GK. GK is 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So this is 6, this is 4, this is 5, this is 5. Okay, so they're saying that AB is as a result of GK. Definitely not, because they have different length. So no. So for our answer is only TU, the first one. Next one. TU is the result of a dilation of GK. Interesting. TU dilation of GK by a scale factor less than 1. TU is this horizontal segment, is the dilation of GK by a scale factor less than 1. So they're saying that they're going from GK to TU, dilating less than 1. Makes sense. They're horizontal, so they have the same direction. TU is 5, which is less than 6. When I dilate GK with a value that is less than 1, meaning I'm going from big to small. Makes sense. If my dilation is greater than 1, then it will make it bigger. Dilation less than 1, make it smaller. Makes sense. Dilation less than 1. Yes. Next statement. RS is the result of a reflection of MN. RS, reflection of MN. How? Reflection over the y-axis, x-axis? Nope. GK is the result of 90-degree rotation of AB. GK, the top, is a rotation of 90 degrees of AB. Remember, AB and GK have different length, so no, it does not make sense whatsoever. You can't make it unless you have a dilation involved, right? The only way is having a dilation between one and the other one. Next statement. Mn is the result of a dilation. Oh, okay. Mn, dilation of AB by a scale factor less than 1. Mn, dilation of AB factor less than 1. First of all, I will need a dilation and a reflection. You see, we had a dilation here from GK to TU because they're horizontal. They have the same direction. But right now, Mn and AB, they have different orientation. And they're saying Mn is the result of a dilation of AB by a scale factor less than 1. But they're not saying anything else. So no, it does not make sense whatsoever. All right, let's go to question number 3. Now we have question number 3. We have a diagram, okay? And they're saying, what sequence of transformations from clip to, okay, so CLIP to CLIP prime. Remember, the prime is the one that is already being transformed. So this is my this is my image. Image is the one that is already being transformed, and the original is your pre-image. Okay, so what is the sequence of transformation from here to here? So pre-image to image, I need to rotate, okay? I need to rotate this and then translate it somehow. If I rotate it, I will be standing in the same position as this, and then I translate it. One more easy way to find out, and you know, many of the problems gives me this, is let's keep reading the questions. Look at part B. What is the angle of rotation? So they're telling me that there's a rotation involved. Let's keep reading. Write the coordinates of the image of point P after the rotation. So they're talking about the rotation. What else? Write an algebraic description of the translation. So they're telling me that it's a rotation and translation. So you see that the answers, they help me also answer my questions, okay? So part A is rotation and translation. Part B, what is the angle of rotation about the origin? Angle rotation about the origin. So the angle rotation, I need to rotate this. Here's a table of easy quick reference. All right, rotation 90 degrees, clockwise, counterwise. So right now I'm going to have a rotation of 270 degrees counterclockwise. That's what I have right now. Okay, so it's going to be a 270 counter. Okay, because remember, this line that is vertical has to go horizontal and then flip 180. So to go horizontal is 90, then the 180 is 270. So I have a rotation of 270 about the origin. And that's question B, 270 degrees about the origin. Question C, write the coordinates of the image of point P after the rotation. So like I said, part C, we're rotating 270 about the origin, but counterclockwise. Remember, the clock goes this way. Counter goes this way. So we're rotating this figure counter 270. All right. So let's go to here and says counterclockwise. So xy, my point xy becomes y negative x. So they're talking about point P. Point P is this point. So it's 1, 2, 3, 1, 2, 3, and 1, 2. So point P is 3, 2. All right, but we're rotating 270 counter. So my point 3, 2 becomes y negative x. Y negative x. My P prime becomes y negative x. What does that mean is the y turns into x, so it's going to be 2, and the x turns into y, and it becomes negative 2, 2, negative 3. So this is the coordinates for this point on the end, negative 3. Please go to the next video, video 2, for the continuation of this problem. All right, subscribe, please like the video, stay tuned.